The quantum world, where the laws of reality break down. Level B, 1. Intermediate. In everyday life, the world feels clear and understandable. If you let go of a cup, it falls to the floor. If you turn on a lamp, light fills the room. If you boil water, steam rises and bubbles appear. We get used to these rules so deeply that we almost never question them. Gravity always pulls things down. Electricity lights our houses. Heat cooks food. It all feels predictable. But this familiar world is only one layer of reality. Below it exists another layer, extremely small and completely different. It is the world inside atoms, inside particles that cannot be seen with the naked eye, inside tiny elements that make up everything around us. This world is called the quantum world, and here almost nothing behaves the way we expect. Quantum reality shows us that the universe has rules that do not match everyday logic. A particle can exist in two places at the same time. Light is not just a wave or just a particle, it can be both at once. Some particles seem to disappear and return again, as if space itself plays tricks. In this strange world, things can remain uncertain until someone observes them. When no one looks, they stay in a cloud of possibilities rather than a clear state. Quantum physics studies the tiniest parts of nature: electrons, photons, quarks, and energy on its smallest level. When scientists explore these particles, the normal rules of the physical world break down. For example, in the classical world, a ball is either here or there. It cannot be in two positions at once. But in the quantum world, an electron can be both here and there, and nowhere specific, all at the same time. We may not like this idea, yet experiments repeatedly show that this is how reality behaves on the smallest scale. One of the most confusing discoveries in quantum science is that observing something changes it. When scientists try to measure a particle's position, it chooses one location, but before measurement, it does not have a single fixed place. It exists in a state called superposition, where many options are possible at the same time. Only when the experimenter looks does the particle pick one of those possibilities and become real in the way we understand reality. This is the famous observer effect. It tells us that at the quantum level, things do not simply exist in clear form without our observation. They behave like clouds of probability that collapse into certainty only when measured. This idea shocked many physicists because it suggests that the act of watching is not passive, it changes the system itself. Light is another example of this strange dual nature. In school, we learn that light travels in waves, which is true, but in other experiments, light behaves like a stream of tiny particles. It is not one or the other, it is both. Scientists discovered that light decides how to appear depending on how we measure it. When studied as a wave, it acts like a wave. When measured as a particle, it behaves like a particle. This means the reality of light is flexible, and our perspective influences its behavior. Quantum physics also shows connections that classical science cannot explain. Sometimes two tiny particles become connected or entangled. When this happens, they behave as one, even if placed very far apart. If something changes in one particle, the other responds immediately, as if distance does not matter at all. Albert Einstein called this spooky action at a distance, because according to classical physics, nothing can communicate faster than light. Yet entangled particles do not follow this rule. This is not just theory. Scientists have repeated these experiments many times, and every time the results confirm that entanglement is real. It suggests that space may not be as separate and empty as we imagine. Something invisible might connect parts of the universe instantly, a kind of hidden communication deeper than physical distance. Quantum science forces us to accept that reality is not as solid and simple as it looks. Even objects that seem solid, like walls or tables, are mostly empty space filled with moving quantum particles. These particles have no fixed shape or position until we examine them. What we call matter is mostly energy and probability working together to create something that looks stable. The deeper scientists look into atoms, the more strange behaviors they find. Particles can suddenly appear on the other side of barriers without breaking them, a process called quantum tunneling. In our world, if you walk into a wall, you stop. In the quantum world, a particle may pass straight through as if the wall is not solid at all. This strange behavior is not just a curiosity, it is the reason the sun produces energy. Without tunneling, the reactions inside stars would not happen, and life would have no sunlight. The quantum world also helps explain why modern technology exists. Computers, phones, lasers, GPS, and many medical devices work because electrons behave as both waves and particles. Without quantum effects, chips would not function, and solar panels would not convert light into energy. What feels mysterious in theory becomes practical in real life. Scientists are now trying to use quantum rules to build new machines, such as quantum computers. These computers will not think in simple bits like traditional machines. Instead of processing information as 0 or 1, quantum computers use qubits, which can be both 0 and 1 at the same time. This ability allows them to solve complex problems at incredible speed, analyze huge data sets, and simulate natural processes that normal computers cannot handle. Some researchers believe that quantum rules may even touch human consciousness. There is a possibility that the brain works not only through electrical signals, but also through quantum states that allow fast decision-making or sudden insight. This idea is still debated, but if true, it would mean that the mind itself uses the same principles as atoms. Quantum physics questions everything we thought was certain: matter, time, observation, and even cause and effect. Events do not always need a clear reason in the quantum world. Sometimes things simply happen spontaneously. Instead of strict rules, we see patterns of probability. The closer we look, the more reality changes shape. What appears solid becomes energy. What appears separate becomes connected. What appears simple becomes a puzzle. Quantum physics does not just describe the world, it rewrites our understanding of what real means. It shows us that the universe is not a rigid machine, but a flexible system full of possibility. The deeper scientists study quantum reality, the more they see that normal logic is not enough to explain how nature truly works. The world we see with our eyes is only a surface layer. Under it lies a universe of moving energy, uncertain motion, and silent connections that do not follow the rules we learned in school. One of the most surprising discoveries is quantum tunneling. In our daily world, if an object reaches a barrier, it must stop, climb over it, or break it. Nothing can simply pass through. But at the quantum level, particles sometimes appear on the other side of a barrier without crossing it in any normal way. They simply vanish from one side and reappear on the other. This effect allows stars to burn for billions of years. Without tunneling, atoms in the sun would not fuse, and there would be no light or warmth on Earth. The strange behavior of particles is the reason life can exist at all. This behavior also shapes technology. Modern electronics depend on electrons jumping through barriers inside tiny circuits. Without quantum movement, computers would stop working. Even the light inside lasers is created because particles behave like both waves and particles at the same time. Quantum rules do not only exist in laboratories, they shape every digital device we use daily. Now scientists are building quantum computers, which may change the world even more. While normal computers think in simple patterns, 0 or 1 quantum computers can think in many states at once. This is because their bits, called qubits, can exist in superposition, meaning they hold multiple values simultaneously. It allows them to solve huge problems extremely quickly. They may help design medicines, predict climate changes, and simulate the universe itself. Instead of processing one step at a time, they can process millions of steps in parallel. In the future, these machines may feel like a kind of artificial intelligence far more advanced than anything we know. The quantum world also asks big questions about reality. One famous example is Schrödinger's thought experiment about a cat in a box. The cat remains both alive and not alive until someone opens the box, because the particle controlling its fate is in superposition. This story is not meant to be taken literally, but it helps us understand just how strange quantum rules are when applied to everyday objects. It shows how different the quantum layer is from ordinary experience. Another idea suggests that when particles choose between possible actions, they may create parallel worlds. In one world, a particle takes path A. In another, it takes path B. Instead of disappearing, both possibilities continue to exist in different versions of reality. While this theory is not proven, many scientists take it seriously because it solves some difficult quantum problems. If true, the universe may contain countless timelines, each with different outcomes. Quantum theory also leads to conversations about the mind. Some researchers think consciousness might not work only through electrical signals, but also through quantum processes. This could explain sudden inspiration, fast decision-making, or creativity that feels instant. If the brain uses quantum connections, then human thought might be closer to the behavior of atoms than we ever imagined. Another unusual idea is quantum randomness. In our usual understanding, every event has a cause. A ball falls because gravity pulls it. A light turns on because electricity flows. But in the quantum world, particles sometimes change direction or state without a clear reason. The universe, on its smallest level, does not always follow strict cause and effect rules. Instead, it works through probability, like a deck of cards constantly reshuffling itself. All of this leads to a new understanding. Reality is not solid. What looks like firm matter is mostly empty space, full of tiny particles moving in patterns that appear and disappear. Your hand, a metal table, a mountain, all are made from energy arranged in ways that feel permanent, but are, in truth, flexible and dynamic. Quantum physics also shows that everything is connected. When two entangled particles respond instantly to each other, even across great distances, they remind us that space is not just emptiness between objects. It may be a network, a kind of invisible web where information travels without limit. This idea changes how we see separation. Things that look independent might be deeply linked at a level we cannot see. Understanding the quantum world is difficult, not because nature is strange, but because humans evolved in a world of large objects, simple motions, and visible forces. Our senses were not built to understand electrons, probability clouds, or invisible states. Yet these small events create everything we experience: light, sound, color, heat, and life itself. Quantum physics also teaches humility. We once believed we understood how reality works, but now we see that our knowledge covers only part of the truth. The universe behaves in ways that challenge our imagination and our logic. But instead of feeling confused, we can feel inspired. We are learning that reality is much richer than we thought. In daily life, we feel the world is stable, but on the smallest level, it is full of movement, sudden change, and hidden patterns. Quantum science shows that what looks simple on the surface is complex underneath. Every star, every atom, every breath depends on rules we can barely understand today. The more scientists explore quantum behavior, the more they realize that reality is not a finished machine. It is a process that continues to evolve, interact, and surprise us. Whether it is light behaving like two things at once, or particles communicating instantly across space, the quantum world invites us to imagine a universe far more creative than our senses allow. In the end, quantum physics is not only about tiny particles, it is about the nature of existence. It tells us that certainty is not guaranteed, that matter is not truly solid, and that space and time may not be fixed. The universe is alive, with possibility, connection, and transformation. The closer we look, the more wonder we find. The quantum world reminds us that mystery is not something to fear, but to explore. When we look deep inside reality, we discover that the universe is not a silent clock, but a bright, dynamic story full of movement, surprise, and endless potential. And perhaps that is the greatest lesson of all. The world is far bigger, stranger, and more beautiful than it appears from the surface.